So first of all, before we can talk about permutations and combinations, we have to talk about a number called, or a symbol called factorial. So for any integer, any counting number, positive integer, when we talk about something called n factorial, we actually use the exclamation point after that number. Okay, so 7 factorial looks like a 7 with a exclamation point after it. Okay, has anybody seen that before? Yes, no? First time through? Okay, so 7 factorial means that we take 7 times 1 less than 7, 6, times 2 less than 7, or 5, times 3 less than 7, 4, times 3 times 2 times 1. Okay, so you keep decreasing your number by 1 every single time until you get down to 1. So far, so good? Okay, so 7 factorial will be 7 times 6 times 5, I wrote 3, 7 times 6 times 5 times 4 times 3 times 2, and that times 1 isn't absolutely necessary because anything times 1 is itself. Okay? Now, everybody have your calculator out? See if we can find that button on your calculator. It's going to save you some time. Or you can take 7 times 6 times 5 times 4 times 3 times 2 times 1. So when I multiplied it out, I got 5,040. Anybody find the factorial button on their calculator? On these guys, it is, where is it at? You actually just multiplied it out, but there should be a factorial button. Might be in the probability section. Okay, so if you want 7 factorial, you would hit 7, and then you hit the probability button, and there's a little factorial button on the right, and you press enter. You arrow over to it and press enter. Okay, so that saves you from having to type 7 times 6 times 5 times 4 times 3 times 2 times 1. Those of you with a TI, it's under math, so you would type your 7, and then you would go over to press math and go over to prob, P-R-O-B, arrow over, and then down to the 4, press enter, or type 4 and enter, and you're good to go. Okay? Everybody find probability on, or the factorial button on their calculator? Good. And again, you don't have to have that button. I functioned for many, many years without ever using that button. It should be in the prob, PRB, I'm guessing. Yep. Okay, and you've got, I don't see factorial out in plain sight, so it's got to be probably in a probability section if your calculator supports it, which it most likely will. Seconds. I don't see it on yours, but that doesn't mean it doesn't. Okay. Yeah, you have to have the 7 first, and then you hit your probability button. Okay. All right, so let's find 5 factorial. 120, because it's 5 times 4 times 3 times 2 times 1. We can actually do this one in our heads. 5 times 4 is 20, times 6, 20 times 6 is, or times 3 is 60, times 2 is 120. Okay? All right. Now, if we wanted to find 6 factorial divided by 3 factorial, we can do some things to simplify that. That's going to be 6 times 5 times 4 times 3 times 2 times 1, which is 3 factorial. But I'm going to stop right there because I also see a 3 factorial in the denominator. And doesn't 3 times 2 times 1 cancel with 3 times 2 times 1? Yeah, so don't waste your time in writing them completely out. Now we just say that this is 6 times 5 times 4. Okay? it's better to at least today write them out so that you understand where they're coming from. And then tomorrow when we work on this one more day, I'll let you do shortcuts. Okay? But it's good to understand where in the heck this number comes from. Okay? So 6 times 5 is 30, times 4 is 120. Everybody get 120 when you worked that one out? Okay, so those are the first 3 in your box on the left-hand side. So make any notes that you need to. And then we're going to define something called a permutation. So a permutation is an arrangement of objects in which order does not matter. Okay, what's that? I'm sorry, thank you. When order does matter. Thank you. Okay, combination it won't. So an arrangement of objects when order is important. Okay, you're placing people. Who gets first place? Who gets second place? Who gets third place? Who's the president, the vice president, the secretary? Okay, when order does matter, who's going to become members of a committee? Okay, who's going to be the officers of the student council? When order matters, when they have a distinction, a title, a specific place or location, then that's when we use something called a permutation. And so I want you to think of P in permutation corresponding to place. Where are we placing them? What special title are we giving them? Okay, so permutation is when order does matter, and we have a symbolism for it. NPR means that we're taking n objects and we're placing them R at a time. Okay, so if we have 24 people in here and we're choosing 3 of you to have a title of a president, vice president, secretary type of thing, okay, the 24, the number of students being chosen from the pool, is the N, and the R is the number of people that get that distinguishing title. Okay? So that's defined as N factorial over N minus R factorial. Okay? So in this example, we'd have 24 people, 24 factorial, divided by 24 minus 3, or 21 factorial. Okay? So far so good? So this is when order matters. We're placing people, specific titles, specific place values in a race, those types of things. Okay? So how many ways can we arrange the letters in the word July? Okay? So this is an example of a permutation, arranging letters in, they're not going to form words, but just rearranging those letters. Okay? So when you're thinking of passwords and so forth. So July, how many letters does it have? 4, okay? And how are we arranging them? All 4, right? 4 at a time, okay? So this is a permutation. We're going to take 4 letters and we're going to place them 4 at a time. Now, by our definition, 4 with a permutation of 4 means that we're going to take this first 4 factorial, and we're going to divide it by 4 minus the second 4, and 4 minus 4 is 0, so we'll have a 0 factorial, and 0 factorial is defined as the number 1. Okay, so we're taking 4 factorial and dividing it by 1. All right, so 4 factorial, 4 times 3 times 2 times 1. What's 4 times 3? 12 times 2. So our answer is, there are 24 ways we can rearrange those 4 letters 4 at a time. The N and the R will be different, absolutely. This is just our first example, okay? So when they're saying rearrange letters, okay, and those letters are unique letters, like July, there's no repeats. It's just going to be however many letters there are factorial, because we're using all the letters and we're going to be dividing by 0 factorial. Okay, so far so good? All right. So how many ways can we rearrange the letters unpredictability? Yeah, I don't have a space for it, but you might have room in there somewhere. Okay, unpredictability. How many letters are there? Everybody count 13? Okay. Are they all unique? Do they ever repeat? Do we have 2 A's or 2 I's? Nope. So we're going to take 13 of those letters and we're going to place them 13 at a time. We're going to use all 13 of them up. Okay, so if you wanted to use the word unpredictability as your password and you were going to scramble those letters, we're going to see how many different ways you could potentially scramble those letters. Okay, so what is 13 with a permutation of 13? 13 taken 13 at a time. That's 13 factorial over 13 minus 13 factorial, which is just 13 factorial. So you can, when you start to see this pattern and get comfortable with this, you don't have to write this out each time. You can just realize this is going to be 13 factorial. So this is where that button on your calculator comes in handy, because now we would have to take 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1 if you feel like it. Okay, the last one is not necessary. What do you get when you do 13 factorial? Yep. Keep going. 20,000, 020. Okay. 800. Yep. Huge. Yes, sir. You could leave it at 13 factorial. I'm just wanting to make sure that you understand what this stands for. Absolutely. Yes. Because that will be a 0. Yep. I just didn't say that that's 13 factorial over 0 factorial. And 0 factorial is 1, so we're just looking at 13 factorial. And that's what you plug in the calculator to get that. Okay? So we learned a new symbol, and then we learned what permutations means. Okay, when order matters, we're placing things, we're putting them in a specific location. Okay. All right, so Mississippi, what do you think? Oh, let's do one more quick one. Okay, before I do that, I forgot that didn't have this space here either. But now this time, as we heard before, Veronica asked before, are we always going to use a 13 or the same number in both? Well, this case, we just want to use 5-letter groupings. Okay, so now we have 13 letters, but we only want to take 5 of them at a time. Okay, so 13 letters taken 5 at a time means that we're going to take 13 factorial and divide it by what? 8 factorial. Why is it 8 factorial? Yep, we have to take that 13 minus 5. So this is 13 factorial over 8 factorial. And if you don't have a calculator that does this for you, and for today we're going to pretend that we don't, we're going to do a 13 times 12 times 11 times 10 times 9 times 8 factorial. And I stop at 8 factorial because I'm going to divide the 8 factorial out. And so if you don't have a factorial button on your calculator, you can save yourself some time by taking 13 times 12 times 11 times 10 times 9. Okay? And what did we get for that answer? I have to start calling on people. Nobody wants to speak up. Or the same people speak up. 154,440. Because it was this crazy 6 billion number, right? And then we're dividing that by 8 factorial. Uh-huh. Yep. Exactly. If these whenever these two match up, that's what we're canceling out, because 8 times 7 times 6 times 4 times 5 times 4 times 3 times 2 times 1 over 8 times 7 times 6 times 5 is going to all cancel out. So we're saving ourselves some writing. Okay? Once you hit whatever is on the bottom, stop writing. Cancel. Okay? So far so good? Great questions. Okay, so what happens if we have letters that repeat then? We only have to count them once, right? Because we don't want the I's, they're not unique permutations, okay? They would be repetitions of previous ones that we had written out, okay? So to do something like this, for unique permutations, we're going to say, first of all, how many letters are there in Mississippi? 11. So we have 11 letters, but how many of them repeat? 3 of them, the I's, the S's, and the P's, right? Okay. How many I's are there? And how many S's? And how many P's? Okay. So what we're going to do this time is we're going to say that we need 11 factorial divided by, we're still taking all of them. So it would normally be 11 factorial if these were all unique letters and they didn't repeat. But now we're dividing it by the 4 factorial, the repetition of the I's, times the 4 factorial, which is the repetition of the S's, times the 2 factorial, which is the repetition of the P's. Bless you. Okay. So let's see how that looks when we write it out. We'll have 11 times 10 times 9 times 8 times 7 times 6 times 5 times this 4 factorial. And I stop there because I know I have another 4 factorial that I get to cancel with it. Okay. But I also have a second 4 factorial that is 4 times 3 times 2 times 1. And then I also have a 2 times 1. Okay, so now we get to cancel things. 4 factorials go away. Okay. This 4 and 3, or this 4 and 2 actually is an 8. So it can cancel with the 8. Okay. And we have a 3 and a 2 that can cancel with this 6. And now we don't have as much to multiply. So if you don't have a factorial button on your calculator, you can do some of these things to help yourself by not having to punch all these buttons in and make a mistake. Okay, you have a question, Veronica? 3 times 2, we're multiplying though. So that's going to be your 6. Okay. All right, so what are we left with? Well, we're left with 11 times 10 times 9 times 7 times 5, which is a whole lot less to multiply out. And we get 34,650. So how do we set up Nebraska? How many letters? 8 of them, right? So we want to take 8 of them, 8 at a time. Should make that smaller. But we have to divide by any repeats. Okay. Which ones repeat? The A's, right? And we only have 2 of them. So we're going to have to divide this by 2 factorial. Okay. So 8 taken 8 at a time is 8 factorial. That means 8 times 7 times 6 times 5 times 4 times 3. We don't need the 2 because we're going to divide that out. And we can rearrange the letters in Nebraska. 8 times 7 times 6 times 5 times 4 times 3 times. So we can get 20,160 unique permutations because we took out the fact that we have a couple A's. So far, so good? Okay. So now let's talk about combinations. Permutation, you're placing them. The order matters, their location. Okay, where we're putting them for a photo in a photo op. Now we're talking about combination, and combination is when order does not matter. Okay, when you're picking toppings on a pizza, does it matter how you pick them when you're ordering for on the phone? I get a 4-topping pizza. Does it matter if you say beef before sausage, before peppers, before mushrooms? No. Okay. So the definition of a combination is that we take n objects r at a time, and it's equal to n factorial over our n minus r factorial, just like we had before. But then we also take it and we divide it by an additional r factorial. Okay, so there will be fewer items in a combination than there will be in a permutation. Okay, so if we're choosing 2 captains from a PE class, do they have a title or a distinction or some special name? Just 2 people randomly chosen from a PE class of 25, right? Okay, so when we're choosing those 2 captains, order doesn't matter, so we use a combination. And we say we're choosing from 25, we're choosing 2. Not placing, not putting in a special location, but choosing. Okay, so 25 choose 2 is going to say 25 factorial over, what's 25 minus 2? 23 factorial. And then we still have to tack on our r factorial, 2 factorial at the end. Okay, that's a combination. So 25 times 24 times 23 factorial over 23 factorial. Those guys are going to cancel. And then I have a 2 times a 1. And 24 divided by 2 reduces to what? Picking an even one here. 12, right? So now we just have to take 25 times 12, and we'll get 300 different ways that we can choose 2 captains from a class of 25? Okay. Everybody good with that one? Yes, sir. Yep. You just stop at the highest number that's on the bottom. That way those two will cancel, less writing for us, and then we add the other two that are necessary. I like to write them directly above and below, but it doesn't have to be. I could have put the 23 factorial over here and the 2 factorial and canceled this way. Okay. All right. Another quick question then. You're thinking about colleges now, and there's 10 of them on your big list. In how many ways can you go visit 6 of them? Does the order matter here? We're not looking at our top 1, top 2, top 3 colleges, right? We just start choosing from 6 different colleges out of 10 to go look at and visit. Okay? So the order, they don't care whether you see one college before another one, right? So order doesn't matter. This is 10 colleges, choosing 6 to go to. We're not ranking them. We're just choosing 6 to go to. Okay? So Kobe, what should I write down if I want to write that out in factorial form? What goes on top? 10 factorial. And now with the combination, what goes on the bottom? 10 minus 6. And then what else goes down there? The 6 factorial, the r factorial. Very good. Okay. So John, how do I write this out? If I want to do some simplifying of it. 6 factorial, right? We want to stop there because that's our biggest factorial. Okay, we'll write it right below it or on the other side, it doesn't matter. And then, Jordan, what's going to be the other part that we have to include? Yep, which is 4 factorial. So 4 times 3 times 2 times 1. I like to write those out because I want to do some canceling and I can see them better if they're written down. Okay? 6 factorials are gone, they cancel. And then I like to pick some numbers. I like to choose even numbers usually. 4 times 2 is a total of, or multiplied to get 8, so that cancels with the 8. And I have a 3 left. This 3 will cancel with 9, and what's left? 9 divided by 3 is 3, right? Okay. So now I have a much simpler problem to plug into my calculator. 10 times 3 times 7. 210. There are 210 different ways that you can go visit those 6 out of your 10 colleges. And then, of course, you're going to probably use logistics, geography, and so forth to help make that decision. Which ones are close together? Can we get 2 of them in one weekend? Those types of things. Okay? All right. So, I'm going to make you hungry here with pizza. But I think you know how to do this now. Okay, this is a combination. Order doesn't matter. Okay. Let's talk about Olive Garden's tour of Italy real quick. Okay. They say, hey, you can start with a soup or salad, and breadsticks are on us. So how many choices do you have right now? 2, super salad, right? Okay, so we're starting with super salad, 2 choices. Then they say, guess what? You get to choose a premium filled pasta. And we have 3 options for you. So now how many choices do you have? 3, right? Okay. Then they say, guess what? Now you get to choose a signature pasta. How many options do they have here? 3. And then finally, oops, we actually don't get a dessert. Okay. So that's your tour of Italy. So how many different times could you go to Olive Garden and not eat the same thing twice? Okay. All right, so we'll finish this up on tomorrow. But try to do everything that you can on the right-hand side.